Demonstration problem 1 on the horizontal projectiles section of group work quiz for chapter 3. The problem is a fully laden swallow is flying horizontally at 15 meters per second when it drops a coconut. Part A, if the swallow is flying at a height of 12 meters above a lake, how far from a point directly below where the coconut was released that hit the water? And part B, what is the instantaneous velocity vector of the coconut as it hits the water? Projectile motion is defined as two-dimensional motion where the only force is the gravitational force or the weight. The first thing we notice is that force has no component in the x direction. Anytime we deal with vectors, and here we're analyzing the velocity vector, we must consider the x and the y components of the motion separately and independently. So, the moment the swallow drops the coconut, it then becomes a projectile motion problem, and in particular a horizontal projectile. The thing to note here is the x component is the 15 meters per second that the swallow was flying when it released the coconut, and since it was flying horizontally, the y component of the motion is 0. So, to break the motion into its x and y components, we consider Newton's second law, which says that the acceleration is the net force divided by the mass. So acceleration and net force are vectors, mass is a positive scalar. And so, since mass is a positive scalar, that does say that the acceleration, which is the acceleration of gravity, 9.80 meters per second, must be in the same direction as the weight or the gravitational force. That's down. That's all y. So we write the second law for the x-axis. And so we see that the acceleration in the x direction is the net force in the x direction divided by the mass. There aren't any x forces. This says that the acceleration in the x direction is also 0. And so what that says is the velocity is constant. So v sub x at all times during the motion is a constant, which is Vx naught. This tells us that the x component is uniform motion. Now consider the y motion. A sub y is the net force in the y direction divided by the mass. But, as we said, the only force for projectile motion is the gravitational force, which is minus mg. The minus sign means in the negative y direction. The mass cancels, and so we get that a sub y is minus the acceleration of gravity. This tells us that the y component of the motion is our good friend free fall motion. In part A, we need to find how far the coconut went horizontally. So symbolically, we need to find the displacement, delta x, from a point directly below where the coconut was dropped by the swallow. We've established that the x component of the motion is uniform motion or constant velocity. The acceleration is 0 by the second law, so v sub x is at all points during the motion the initial x velocity Vx naught or 15 meters per second. So Vx naught continually until the coconut hits the water and then is no longer a projectile problem. So, uniform motion, that says that the displacement x minus x naught, and conveniently x naught is 0 when the swallow drops the coconut, is X is Vx naught, or 15 meters per second, times the time that the coconut hits the water. And so we need the time that the coconut hits the water. It really goes this path, but the y component we've established is just free fall. So it's equivalent to saying you drop an object, a coconut, from a height of 12 meters. How long does it take to hit the water below? The motion is uniform motion. The coconut travels at a constant velocity of Vx naught, 15 meters per second, until it impacts the water. So to find how far, we need X is Vx naught, or 15 meters per second, times the time that it hits. To find the time that it hits, we take advantage of the fact that the y component of the motion is free fall motion. It is identical to the problem of you drop a coconut from an initial height of 12 meters. How long does it take to hit the water below? If you drop the coconut from 12 meters, it would hit the water below at exactly the same time that the coconut moving in 2 dimensions would. So we write down the final velocity not known equation, which is a quadratic equation. Delta y, the y displacement, which is y final minus y initial, 0 minus 12, or minus 12 meters is the y displacement, is Vy naught times the time that it hits minus half the acceleration of gravity of 4.9 meters per second times time that it hits squared. Since this is a horizontal projectile, the key fact to note is that Vy naught is 0. That takes out the linear term, and it obviates the need for having to use the quadratic formula to solve for the time. So we can simply divide both sides by minus 4.9 and then take the square root of that and get the time that it hits is 1.56 seconds. And then substitute that into the x uniform motion problem and get x hit is 15 meters per second times 1.56 seconds, or 23.5 meters. Part B is, what is the instantaneous velocity vector of the coconut as it hits the water? So velocity is a vector. This means we need the x component of the velocity vector at the instant it hits the water, and that is simply Vx naught, which is 15 meters per second. And then we need the y component of the velocity vector as it hits. And once we find that, then the polar magnitude, which is the speed when it hits, is very simply the hypotenuse of this right triangle. And that would be Pythagorean theorem. And then the depression angle, theta ref, actually a fourth quadrant angle, but we'll just say below the horizontal, is an inverse tangent. It'll be the angle whose tangent is the opposite side, which will be Vy hit, over the adjacent side, or Vx naught. Vy hit is found using the equation Vy hit is Vy naught, which is 0 since it's a horizontal projectile, minus the acceleration of gravity times t hit, which we found to be 1.56 seconds. This gives us a Vy hit it's actually negative 15.3 meters per second. We now know both sides of this right triangle and can solve for the hypotenuse, which is the speed that it hits, and then the reference angle, the angle below the horizontal that it hits. So we calculate the speed V hit that the coconut impacts the water as a Pythagorean theorem, square root of the sum of the squares, the x component, which is Vx naught, or 15 meters per second, squared, plus the y component, which is minus 15.3 meters per second squared. That gives us a V hit of 21.4 meters per second. And then we need theta ref, or the angle below the horizontal that the coconut hit the water. That's an inverse tangent absolute value A V hit divided by Vx naught, the opposite side over the adjacent side. The opposite side is Vy hit, the adjacent side is Vx naught. And so that gives us angle whose tangent is absolute value of minus 15.3 meters per second divided by 15 or 45.6 degrees below the horizontal. And that's it.